Hello there. Let's look at the next LeetCode problem. This is problem 53, maximum subarray. Given an integer array nums, find the subarray, the largest sum, and return its sum. A subarray is a contiguous non-empty sequence of elements within an array. Alright, so example 1, we have -2, 1, -3, 4, -1, 2, 1, -5, 4. So I think we can do it this way. If we look at just the first one, then we take -2, then we see 1, then we take 1, then we see -3, then we see 4, then we have -1. I think when we see -1, we take the previous value, then we have 3, then we see 2, we add it up, we see 1, we add it up, we see -5, stay positive, so we take it. Hopefully we can get a larger number. Then we have 5. So maximum here is 6. Yep, so we got it right. Answer is 6. Example 2, we have just 1. So in the end we just have 1. Example 3, we have 5, 4, -1, 7, 8. So we take 5, and then we have 4, we add it up, -1, it's pretty good, we take it, 15, and then 23. So we have 23 here. Alright, I think I got the problem here. I just would like to clarify a few things. May I know the length of the nums? So it's given by between 1 to 10 to the power of 5. Significant and concord. Okay, there is a follow-up there. It makes me curious. If you have figured out the ON solution, try coding another solution using the divide and conquer approach, which is more subtle. Okay, let's work on the ON solution first. I think I got the question now, and I have all the necessary information. So based on what I did in the example questions, I would say one possible approach is hold on a second. Okay, so one approach that we could do is that we move along the array, and then we take the previous maximum subarray. If it is still positive, then we take it. If it becomes smaller, then we might as well just take the current value alone, or we just leave alone. Yeah, so we basically try to maximize the value as we go along the array. Does this sound reasonable to you? I am pretty good at this. May I proceed to coding? I would like to proceed to coding unless there is a further optimization that you would want me to explore. Alright, so I think it's good enough. So now we're gonna move forward to programming. What we're gonna do here is that I will take a value. I'm gonna say m as our maximum, and I will initialize to the first element in the array. Okay. Now the next thing we're gonna do is we will look through all the value starting from the second one. And don't forget, we also need another variable for the solution. Initialize it to nums of 0. So now what we're gonna do is we take m, it will become max of m plus nums of 0, or we just restart it from the nums. Okay, and then the solution, there will be the max of solution and the current max. Then we return m. Okay, now, alright, let me quickly go through the code again to make sure I don't miss anything. Okay, first of all, create a variable m to store the maximum subarray if we take the previous maximum and then combine with the, the m will represent the maximum subarray given the array is from the beginning up to the current index of the nums. So there are two ways this could be represented. There are two possible values for m, which is the m plus the current number, or we just take the current number by itself. And in each iteration, it is possible that we have found the maximum subarray, so we take the solution, and then we take the m, and then try to maximize it as we go along the array. Now let me test the code with our example input there to make sure it works as expected. In the first example, we have -2, then we see 1, -2 plus 1 is -1, so we just take 1 alone. So far our maximum subarray is 1. Then we see 3. Basically here we just take the value there. So let me write down here 4 minus 1 2 4 minus 2, and then we have 1, then we have -2, we have 4, we have 3, then we have 5, we have 6, 1, and 5. So the answer here is 6. Sample 2, we have just 1, so the answer is 1. Sample 3, we have 5, 4 minus 1, 7, 8. So we take 5 plus 4, then minus 1, we got 8, plus 7, 15, then 23. Alright, so now let me input our solution into LeetCode to make sure it works as expected. Solution for I in range 1 nums of 0, or we just take nums of 0. Actually, we can pull out the nums of 0. So what we are left with is max of 0, comma n. But this works too. Then the solution is max of solution and the m. Finally, we return the solution. We got it wrong. So let's see why we got this wrong. M solution nums of 0. Oh, okay, so this is nums of I. Yep. Correct, but why does it appear to be quite slow there? Funny. Very funny. How come there is a faster solution there? It makes me curious. So let's look at some solution there. And yeah, I think it's pretty much what you're doing. Actually, let me try to submit it again. Yeah, we got it quite slow, but other people they kind of get it quite fast. Is it because of the way I loop it? Or the num in range? Nums. Then here would be the num. Let's put here minus inf. Actually, I can't infinite. Yes, somehow this is much faster. Okay, then we got the solution. Let's quickly go back to the follow-up question. Code another solution using the divide and conquer approach, which is more subtle. I wonder why we need a divide and conquer here. Okay, I think what we can do, if we want to do a divide and conquer, then we take a prefix sum, meaning that for each number we just create an array which at an index I, it will represent the sum of all the value from zero from the beginning to the current index. And then based on that, we do a binary search on the array. And while doing so, we try to find the value where we maximize the uh, the pivot, if that makes sense. So in the end, hopefully, I will get the solution. Not sure if that could work, but I think it could. Yeah. So I think there are many ways to do it, but I just don't see a use of why I would like to do a divide and conquer. Let me think for a second and then, but I think I will just skip this one. Okay, so I think we will stop here, everyone. Thank you.